Hello everyone and welcome to the 24th video in the top-down zombie game tutorial series. And guys, so if you want to stay updated and notified whenever I upload new content, you might just as well go to my channel and subscribe and hit the little bell icon, notification icon, so that you get all, and you select it to all, so that you get all, so that you get notified whenever I upload any new content and new tutorial videos. So yeah guys. So now let's begin. And in this video we are going to be making the game camera. Now before we get started, there's one thing that I need to go ahead and fix. So previously when we were on the program, previously we could see that the size of the I fixed it somehow. I fixed that off the screen. Anyway, so if I open this and go to gameplay, well, the reason that we were getting a small map was because this was 640 and 480. You just need to change these values to 1500, and it shouldn't be 1500 actually. It should rather be the to the width and height. So height and width. And there we go. And in fact, since we created the renderer, we also this object also has a renderer. So we're simply going to say render. We're just gonna use a renderer. So that we're gonna say renderer equals to new renderer. And there we go. And instead of rendering this through this, we're simply going to be, before we get started, let me just do this. Fix this first. Float to int. So typecast this from float to integer. And now when we run this, okay, we have this going on. Okay, so that's fine. Now after this we need to so we need to create we need to say renderer equals to new renderer, and instead of using graphics.drawImage, I'll be using renderer.drawImage. So we just need to remove all of that and simply say renderer.drawImage. Graphics 2D position transform, and there we go. And yeah, so all of this should be working. And yeah, so basically what I did up to now, so recap on the previous video. If this wasn't in the previous video, then I probably edited all this stuff off screen. So yeah, so the renderer is inside the game object class. So basically every single class that extends from a game object, every single object that's in the game, including a scene, needs to have a renderer in order for it to render. So yeah. Now to get started with the camera, I need to open up Paint and try and illustrate this to you guys. So paint, my dear friend. So now, what is a camera? A camera is basically something that basically allows us to see something. It's a viewport basically. So for example, if this object was our camera and this is our viewport basically, so the camera, the objects, so basically a camera has a viewport around it. So yeah, so what does this mean? It actually, what means is that when, for example, let me just draw the object. So this is, let's say, a house, and the star is the camera, and the rectangle around the star is the camera's viewport, and this is the map. So if this is the map of the game, and so basically what will be rendered onto the scene, for example, is basically the viewport of the camera. So you see, for example, what's being drawn inside the zombie game's window is basically what the camera sees. This, and this. Now if I want to get to the house, number one, the house needs to be within the range of the viewport of the camera. So for the house to be displayed, the house needs to be in here. So I'm just gonna draw another new house because you can't move objects in paint. So I'm just gonna draw a new house, and there we go. Now if this house, let's just pretend that this house is no longer there. Okay, let's not pretend, let me just erase it. There you go. So now let's say the house has moved to here. Now it will be visible inside the game. So what this means is that basically when we play the game, when we're playing the game, what we see is basically this. This is what we see. But what exists isn't just that. The whole thing. This is the whole map. Everything here exists. Everything in this map exists. But when we play the game, only this, what's inside the viewport, that's what we can see. Unless the camera moves around. So there we go. So with that logic, let's get started with the camera code. So I'm gonna go ahead in the camera, to the camera, and go to, we're gonna create a camera inside the graphics package, the camera class. I already did create a camera class, and we're going to have a few values. So first thing we're gonna need to know the viewport width and the viewport height. So we're going to simply say we need to know the position of the camera. That's first thing. Vector 2f. I'll simply name it position of the camera. And the other thing is the other thing that we need to know is the viewport width and the viewport height, which is basically the let me go back to paint. It's basically this from there to there and from this to there. So I will simply go to float. Let me zoom. Flash versus zoom. So we're gonna go inside here and we're gonna create two float variables, and I will name it as viewpoint width, VP width, and VP height. And we'll simply go and create a camera, yada yada yada, and there we go. So I think I'll just remove this. So we need to have, yes, we're just gonna have all of this. So I'm just gonna leave it public. I'm gonna make it public because I'm a lazy person. I don't like to use functions, methods, because you have to type a lot of words. But you can make them private and then generate setters and getters, or write down code for that. So you can simply write get position. You can type it down the hard way, but I'm a lazy person, so I'll just right click, go to insert code, getter and setter, click on the whole class. Now in fact, just setters. We're just gonna be putting setters, so I'm just gonna right click, insert code, generate setter for all of the stuff, and also add a get position. There we go. Hooray to the lazy kids. Lazy kids rock. Anyways, so now we're done with this. Next thing is, so the camera is basically done. Now we need to go to our renderer, and before we do all of this, first every single game object, let me just remove all this stuff. So basically, before we move on to this, every single game object, it's a game object that is visible, has to be inside a scene. Remember, that's the model we created. So we need to go back to the scene, back to the game object class, and refactor and do a lot of refactoring within the game object. So we're gonna go at the top and we're going to create a protected scene, and there we go. Allow imports, generate getters and setters. So I'm gonna simply do this. Now in fact we just need get scene for now. Get scene. Now after that after doing that we need to go and put it inside the constructor. Scene, and we're simply going to say this.scene. What? This.scene is equal to scene. So first thing, and zam, there we go. Control S, Control C. Just gonna copy that. And now let's go to entity, and we're also gonna change out the entity. We're gonna simply say I'll take scene and simply say this dot scene. We're gonna pass that in, and we're just gonna simply pass scene up there, and there we go. To go, and the other thing is to go to the player. Okay, Control S, save. Control S, and we should have a problem in here. We need to change the player. I don't know why is the problem not coming. Let me just run it. Oh yeah, oh, we also need to have a scene in here. Sorry, my bad. So scene, that's why this probably wasn't working. And also need to change the other constructor for the game object, so they can also take a scene with this constructor. So scene, and we're gonna copy this code. This.scene is equal to scene, and after this I'm just gonna and after that let's get back here. Now the player is going to need this code, the entity. So we're just gonna simply pass down the scene. There we go. Shift Control S, we save all, and now we have a problem with the player class as I was expecting. Now we're gonna pass in a scene, and we will also be passing down a scene. There we go. Now the other problem is gonna have in the gameplay scene and the two scenes, the welcome scene and the gameplay scene, because scene extends game object. So scene doesn't have to have a scene because it's a scene. It's a game object, but it doesn't have to be seen. So in fact, I'm gonna simply just say so I'm gonna go to game object and create a new constructor, one without the scene. Control C, Control V. So this constructor will just be used for scenes, for creating scene objects. Remove all of this, and we're simply going to say nothing, and then inside our scene class we're simply going to say, right after calling that method, we're going to simply say scene equals to this, scene is equal to this. And now refresh. Now we need to go to the gameplay scene, and for the player we need to just simply change that and add this, and everything looks fresh. Now we're good to go. Now everything's working pretty fine. Now if we run this, everything's working fresh. Let me just close this one, and there we go. So everything's working fine as it should be. Oh, the other problem that we need to do is to, since we scaled up the size of the map, we also need to scale up the size of the player. So let me just go to the player class, and maybe make this guy's width and height to 100 and I don't know, 25 by 125. And there, now when we run it, the player's size should be somewhat okay. There we go. There we go. Now the player looks kind of fine. I'm okay. I'm fine with this. Now we're done this. Now let's go to the renderer. And basically before getting started with doing this, I just forgot one more concept I need to share with you guys. So when the object, for example, let me just draw back that map, that house. Arrows make wonderful houses. So yeah, anyway, so I'm gonna go take an eraser and erase out this house from the scene. And yeah, so basically, before this, we need to understand, before getting started to doing all of that, we need to understand that there's two different coordinate systems when you're playing a game. So there's one thing that is called the screen space or screen transform, or the screen space or the screen coordinate system. So this is basically the coordinates of the game of your window, which will always start from 0 on the width and 0 on the height, and it's going all the way to 640 on the width and 480 on the height. But our game is 1500. Wow. So it's 1500 by 1500, and this is the position 0 and 0 inside the world of the game. So this object, the position of this object would be, so in order for this to be drawn onto the scene, first of all we need to convert this object's position or location, or the position of this object, into screen space basically, because right now when this object is drawn, it's drawn on the world space and not in the screen space. For us to see it, it needs to be in screen space, not necessarily here, but if this was in the world space, it would probably be somewhere around 100 on the x, that's 1000, 100 on the x, and something around 150 on the y. But if this same object was in the screen space coordinates, this will be on something like minus 100 on the x and minus 50 or 20 on the y. It doesn't really matter. So what does this mean? So when we look at the position of the world, which this whole thing is the size of a world or our scene or our game, and this is basically the size of our window or whatever we can see. When we have the size of the window, damn it, I closed this program. Okay, when we have the size of the window, as you can see, when I press enter to play, this is not the full map that we're seeing. So basically, if this was basically our map, we're only seeing this area. So what we're seeing is basically, if the road was going something, this is basically the road going something like this, and then it's turning at this point. This is the only thing we're seeing. We're not seeing the other part of the road. So basically what we're trying to do is basically convert all of this into screen. We're basically trying to convert these coordinates to screen coordinates, and that's what we're trying to do. So now, to do that projection, or the transforming of the world coordinates to screen projection coordinates, we're going to need two very important data, and that is the first thing is the camera's position. That's the camera's position, and the other thing is the object's position, what we're trying to draw. We need to have the position of the object that we're trying to draw. And how do we calculate the projection of the, I don't know how to say, how do I calculate the drawing, the rendered, I don't know, the screen space coordinates? So basically, I'll take away whatever this is, I'll take whatever this is, the position of this x position, and the camera's x position, and I'll take away the camera's position from the object's position, and I'll get an offset, a displacement value. An offset is basically displacement, an offset, which is going to represent the distance between this and this. With this value, so whatever value I get, this will be part of the answer. So this will be part of the coordinate. So I'll call this x offset or whatever. My handwriting is good. X offset doesn't look like an offset to me. It looks like off something. I don't know. Almost look like Egyptian, ancient Egyptian. This thing over here, and it's losing focus. Anyway, so yeah. So the offset is going to be part of your answer. So if you have a negative offset, then you know that the object's on the left side. If the offset value is positive, then we know it's on the right side. Same with the y offset. So if the y offset is positive, we know it's on the bottom, at the bottom side. It's below your camera, and if it's negative, it's higher than your camera. It's higher. So yeah. So now that we have these offset values, we just have the values. So for example, if I have something like that, so when you calculate the offset, so if you have something that's at 0 and 0, for example, this, I don't know, let's say if the object was somewhere here, then it means it needs to calculate this and this. So the camera's position minus that position is going to give us 0, and we're going to draw it there, and we're going to draw it at that position. So that gives us part of the answer. Now, what's the other thing that we need to make sure? So what if the thing is here? So let me not talk a lot. Let me just get into the programming first. So let me just close this and get program. So we're gonna just do that. So first of all, we're just gonna be calculating the offsets. This is the first step. So we're simply going to say x offset float x offset offset amigos offset takeoff and Quavo and yeah, x offset. So we're gonna say x offset is equal to the position, this position. Damn it, Control Z. We're going to say this position equals to position dot x take away camera position dot x. Camera position dot x. Camera dot position. You can use the get position if you made it a private, but I made it public, so I'll simply just say camera dot position dot x. Oh yes, guys, and the other thing is when we're starting to refer to camera, we just need to go to the scene class, and every scene must have a camera, so we need to simply go and create a camera object. So what I did is I went ahead off screen, and inside the main package, the main class, top down zombie game Java, I just moved this stuff. This code used to be here, but now it's here. So basically it's going to make our viewport or our resolution public, static and public, so you can access it. So I'll simply just go to scene and basically set the camera to top down zombie game dot whatever. I think I also made it final. No, I did not make it final. So anyways, so what we're doing now is let's go to scene. Yes, so we're in the scene. I'll simply say camera equals to new camera and a position. We're gonna give it a position of new vector 2f something by 300. I'm gonna go with 300 by 300. Doesn't really matter where you position your camera. 300 and viewport width, I'll simply go with 640 by 480, but it's not that. I'll simply just say top down zombie game dot width and top down zombie game dot height. And after that we can now go into our renderer and do this. So camera position dot x, and the other thing is float x offset, and then we have to have a float y offset equals to position dot x minus camera dot position dot y. There we go. So, and the other thing is, so instead of passing down the transform, we're going to change this and pass down the rotation instead. Rotation, float rotation, float rotation, float rotation, and we're going to change this stuff. So I go back to the game, because if we try to run it, it's going to give us errors. So we need to go refactor some stuff. So I need to go back to this, to the renderer, no, not the renderer, the player. Since I changed the function, okay. So I need to change both of them from transform to rotation. The reason being is we're going to be creating a transform object from within the here. Float rotation. Now we're going to go to a player class, and instead of passing the transform, we're simply going to pass the rotation angle. Rotation angle, and transform equals to find transform that get translate instance position dot x minus width divided by 2. There we go. Inside our renderer, we're going to do this. So we're going to say transform. So we're going to create a new affine transform. Instead of this, we're going to create it as a field inside here. Let me just zoom. I keep forgetting to zoom. So inside here, I'll go create public affine transform. Transform. There we go. And inside the renderer, I'm simply going to say transform equals to new affine transform. After that, we're simply going to say affine transform equals to transform dot set transform equals to transform dot get translate instance it's equal to affine transform. Damn, I haven't worked with transform in forever. But get translate instance, and we're just gonna simply copy this, Control C, and paste this here, Control V, and copy this code and paste it here. Let's go. What else did we do with the player? We center the transform position dot x minus width divided by 2. So what here we'll do is position dot x so we're gonna simply pass in x offset, because that's what we're gonna be using to draw. X offset minus width divided by 2. And here we'll go with y offset minus height divided by 2. HEIGTH, divide that by 2. And here, inside here, I'll simply say, instead of width, Where's width coming from? I have no clue. So there is no width. Anyways, so we're gonna simply say image.width, image.getWidth divided by 2. Image.getWidth. Now I'll simply go ahead and say float width and height. This is going to be equal to image.getWidth, image.getWidth, width. There we go. And this is going to be equal to image.getHeight, image.getHeight. Or in fact, let me just delete this function. Let's just use this. It's generating too much work that we don't need. So graphics, map, position, and we're simply going to say width and height. Because that method was generating lots of work that we do not need to have. Control Z, Control Z, Control Z, Control Z. Shift Control Z, Shift Control Z, Shift Control Z. Okay, I need to go back and look at my function inside the renderer. So it's image. Oh, it's ending with width and height. So I need to copy, cut, scissors, and paste with toothpaste. But this says this. Oh my goodness. Oh, we're removing a fiend transform. I forgot that we removed a fiend transform. Graphics, profit image, graphics, vector, float. Okay, what's up? So image, graphics, position, float rotation, float width, float height. Okay. Position, rotation of 0, because we're not going to be rotating the map anyway, so now we just have to fix the render. So everything else is fine, and now let's go back. And now what were we doing? I forgot. Okay, yeah, so this is what we're doing. And there we go. So we have this. Now we're going to set the transform to this. And after this, we're going to simply... But there's no errors. Is there an error in this file? I don't see any error in this file anyway. So transform, we're going to set transform to that. We're going to draw image to width, height, and set transform to this. H-E-I-G. Oh yeah. H-E-I-G. So it should work. I don't know why it's not working. So let me just try close NetBeans and then opening it up again. Hopefully the errors goes away. So that's an error. I don't even know what the error is. Okay. Oh, spelling error. H-I-G-T-H. H-T, that's height. And now when we run this, and when I press enter, null pointer. What's the null pointer exception? Draw image. So position.x. Seems that we don't have a position, or we don't have a camera position. Oh yeah, we don't set the camera. We don't set the camera. So what we need to do for every game object is every game object, when you create a new game object, so we're going to simply say renderer.setCamera to what camera is it? What camera? It's the scene.getCamera. And now if we run it, everything should be fresh. And now we should enter. Okay, still I'm getting null pointer exception. Camera.position. Okay. Let me just see if camera is null. Okay, so camera is null. So I need to go to the gameplay scene. I saw it in every single scene I created a camera. Camera equals new camera 300 top down zombie.width, top down zombie.height. That's when we create a scene, right? But for some reason it's not working. Okay, let me go to gameplay scene. And after creating the scene, I'm just gonna call the super function, right? So let me just display camera to see if it's working. Okay, I think we just need to create a camera in every single scene. So I'll simply go to scene and copy this. In fact, just copy and paste, cut this, go to the welcome scene, and inside in it, I'll simply just paste this, Control V, yeah, whatever. So initialize, and where's the gameplay scene? Gameplay scene. Where is it? Before adding a new object, we do this. And when we run this, it's still giving me a null. Why is it giving me a null? Position.x. But we create the camera. Okay, let me just try and figure this out off screen. So yeah guys, so I managed to fix the problem. The problem was basically it was building a null pointer exception right over here. Shift Control and Z. Yes. So basically what was happening is we're not setting the renderer object a camera, and if we're doing that, we're doing it late. So what I did to fix the error, first thing, I just moved over initializing all game objects inside the scene at the very end of the scene. And the other thing is when you start the scene, so inside of the scene class, what I think everyone should do is, before calling init, is where's the gameplay scene? Gameplay scene, there we go. So instead of this, so we're just gonna simply cut this, and I'm going to initialize the camera from the scene. Control V. So camera equals to new that. We also need to initialize the render from the scene class and not the gameplay scene. Where is the gameplay scene? And move, cut you and paste you here. Yeah, whatever. And then after that, we're simply going to say renderer dot set camera to camera, and there we go. Just like this, nice and neat. And yeah, now if we run it, we can see that there you go. Camera is working nicely. It's working like a charm. So guys, stay tuned for more videos, and yeah, so subscribe so that you can get updated on my new videos, and hit the notification button if you haven't, so you can get updates on all my new videos. And yeah, so and everything else will be done in the next video. And yeah guys, so yeah, peace.